Hi, I'm McKenna Brown.
I'm Natalie Grant.
And I'm Lindsay Layton.
And today we're going to go over soy and the reduction of breast cancer risk.
For centuries, soybeans have been a staple food in Asian cultures. Soy contains all 9 essential amino acids, and its composition resembles high-quality animal proteins. In Asian cultures, soy can be consumed in many different forms, as seen in this table. It can be consumed as tofu, which is coagulated soybean curds. It could also be consumed as tempeh, more popular in the Indian region, which is fermented soybeans pressed into cakes or patties. Miso soup is very popular, especially in Japan, and it is a fermented soybean paste. Natto, also popular in Japan as a breakfast food, is a sticky web of fermented soybeans. Okra, a pulp that remains after pureed soybeans are filtered in the production of milk and tofu. It could also be consumed as yuba, which is soy milk skin. So soy milk is heated up, and then when the skin forms on top, it is collected and dried in sheets. It can also be consumed as soybean sprouts. Kanako, which is soy flour, or even hoba miso, which is made by mixing the miso paste that I mentioned earlier, leeks, shiitake mushrooms, pickles, and other ingredients, and then placing them on top of a dried leaf from the ho tree, which is a type of a magnolia, and then that is heated over a charcoal fire. Why is soy and breast cancer being studied? In 2002, there were 1.15 million new cases of breast cancer worldwide. In 2009, the last year with available statistics, according to the CDC, there were 211,731 cases in the U.S. alone. Aside from skin cancer, breast cancer is the most common cancer among women. It has been shown that breast cancer rates are higher in North America than in Asia. One of the hypotheses is that this is due to soy intake. The average isoflavone intake from soy among Japanese and Chinese cities is 25 to 50 milligrams per day, whereas the average U.S. consumption is 2 milligrams per day. So, studies look at Asian intake of soy isoflavones to help determine reduction of breast cancer risk. And this is because soy intake among non-Asian populations is too low to be expected to produce biological outcomes. Therefore, any relationships that might be viewed in Western populations are more likely to have occurred by chance. So this is a major reason why scientists choose to study Asian populations. There have been studies that have suggested that consumption of soy during childhood greatly reduces breast cancer risk. These studies found that consumption of as little as 1 serving of soy food daily, providing approximately 5 to 8 grams of soy protein and 15 to 25 milligrams of isoflavones, may reduce the risk of breast cancer by as much as 50%. One study reported that consumption of soy between the ages of 5 and 11 years was twice as protective as was consumption as a teenager. 2 of the isoflavones found in soy are genistein and diadzin, which are metabolized to genistein and diadzine. These enter the body as glycosidic conjugates that are water-soluble and must be cleaved by enzymes before they can be absorbed. Genistein is more hydrophobic, so it is more readily taken up into cells where it might be able to exert its effects on estrogen receptors, which there are 2, estrogen receptor alpha and estrogen receptor beta. Genistein has a binding affinity for estrogen receptor alpha of 4% and 87% for estrogen receptor beta when compared to estradiol or estrogen. The binding affinity for diadzin, on the other hand, is much less. For estrogen receptor alpha, it is 0.1%, and estrogen receptor beta, it is 0.5%. At concentrations of greater than 10 micromoles, growth inhibition occurs through estrogen receptors, so it is said to be an estrogenic agonist. At concentrations less than 1 micromole, growth stimulation occurs. This level is one that is more achievable through dietary intake. Not only does the effects of isoflavones depend on concentration with regard to estrogen receptors, but it can also depend on life stage. There was a pilot study that showed that premenopausal women had greater epithelial hyperplasia than postmenopausal women when consuming soy protein. This study, however, did have its limitations, including not having a control group, and it was also a shorter duration. Nevertheless, this study did provide some doubts as to the positive effects of soy intake on breast cancer risk through the modality of estrogen receptors. Isoflavones also have estrogen-independent effects. One estrogen-independent effect of genistein is that it modulates genes that control cell growth and apoptosis, which is important in cancer cell death. It also inhibits activation of the nuclear kappa B pathway. What is that, you might ask? It stands for the nuclear factor kappa light chain enhancer of activated B cells. This is a protein complex that controls the transcription of DNA. It's found in almost all animal cells and is involved in the cellular responses to different stimuli like stress, cytokines, free radicals, UV radiation, oxidized LDLs, and bacterial or viral antigens. It plays a key role in regulating response to infections. Kappa light chains are critical components of immunoglobulins. Faulty regulation of this pathway has been linked to cancer, inflammatory and autoimmune diseases, septic shock, and more. It is a protein responsible for cytokine production as well as cell survival. The other pathway that genistein inhibits is the AKT signaling pathway. This stands for protein kinase B, which is a serine threonine specific protein kinase that plays a key role in many cellular processes, including glucose metabolism, apoptosis, cell proliferation, transcription, and cell migration. It binds to downstream effectors like our friend nuclear factor kappa B. When activated, this nuclear factor kappa light chain enhancer of activated B cells transcribes pro-survival genes, thus preventing cancer cell apoptosis. AKT1 has been implicated in angiogenesis as well as tumor development. Under some circumstances, AKT was shown to overcome the cell cycle pause in G1 and G2 phases. So, when activated, AKT may enable proliferation and survival of cells that may have mutated genes, which could contribute to acquisition of mutation in other genes. In essence, it helps the spread of cancer. Isoflavones have been shown to inhibit activation of both of these pathways. Genistein also inhibits activation of tyrosine kinase signaling pathways. Tyrosine-specific protein kinases phosphorylate tyrosine amino acid residues and are used in signal transduction. They act primarily as growth factor receptors and in downstream signaling from growth factors. Diadzin does not exhibit inhibitory effects on tyrosine kinases. An example of a tyrosine-specific protein kinase is the vascular endothelial growth factor receptors, or VEGFRs. They are involved in angiogenesis. Members of the vascular endothelial growth factor family stimulate cellular responses by binding to tyrosine kinase receptors, or the VEGFRs, on cell surfaces, causing them to become activated. Soy inhibits this activation. Finally, genistein can also act as an antioxidant. It scavenges free radicals and inhibits the expression of stress response-related genes and reduces their contribution to the progression of carcinogenesis.
Now we're going to transition into talking about the studies that support this evidence. The first one is soy isoflavone intake and breast cancer risk in Japan from the Takayama study. The objective of this study was to assess associations of soy and isoflavone intake with breast cancer incidence in a population-based prospective cohort study in Japan. The population for this study was unhospitalized residents of Takayama City in Japan. These people were aged 35 years or older in 1992. Over 31,000 people filled out the questionnaire. 17,125 women participated in the study, but the final analysis included only 15,607 women. The baseline for this study began on September 1, 1992, and the study ran through March 31, 2008. Diet was assessed using a baseline survey with 169 questions and a food frequency questionnaire. 9 questions were about soy foods. This included miso soup, tofu, deep-fried tofu, fried bean curd, dried bean curd, fermented soybeans, hoba miso, soy milk, and soybeans. They estimated isoflavone intake using these foods and the Japanese Standard Table of Food Composition. They also gained other environmental data during the baseline survey. This included age, body mass index, physical activity, smoking status, alcohol consumption, education, age of menarche, age of first delivery, menopausal status, and history of hormone replacement. During the statistical analysis, they adjusted for all of these items. Based on the intake of amounts of soy and isoflavones, the participants were divided into 4 different quartiles based on intake. quartile 1 being the lowest and quartile 4 being the highest. Among all participants, soy intake was not significantly associated with incidence of breast cancer after adjustments. The p-value for this was 0.14. These adjustments were the same environmental factors that I explained on the previous slide. Decreased relative risk of breast cancer was observed in quartile 2 of isoflavone intake when quartile 1 was the reference group. This has a hazard ratio of 0.61 with a 95% confidence interval of 0.4 to 0.94. When separating post- and premenopausal women, relative risks of postmenopausal breast cancer was lower with higher intakes of soy. The table at the bottom shows the hazard ratio for both soy and isoflavone. Hazard ratio is a relative risk of developing breast cancer in this case. So, to explain the table in short, compared to quartile 1, postmenopausal women had a lower relative risk of breast cancer with higher intakes of soy and isoflavones. Overall, researchers found that soy and isoflavone intake had a protective effect against postmenopausal breast cancer in a rural Japanese population. The risk reduction effects do not decrease after a certain amount of soy. This study was given a grade of a B+. The analysis takes into consideration other factors and is inclusive for who participated in it. Very few restrictions were in place during the statistical analysis so that as many people could be included as possible. The researchers provided both the p-value and the confidence intervals for their research. The next study we reviewed was soy, isoflavones, and breast cancer risk in Japan. The objective of this study was to examine the possible association between consumption of soy and isoflavones and the risk of breast cancer. The population for this study was part of the Japan Public Health Center-based prospective study on cancer and cardiovascular disease, or the JPHC study. It included 37,435 women and over 27,000 men who were aged 40 to 59 years. The baseline for this study was January 1st, 1990, and the study ran through the end of December of 1999. Over 200,000 person years were followed for more than 21,000 women. Participants were followed from January 1st, 1990 until they were diagnosed with breast cancer, emigrated from the study area, passed away, or until the study completed on December 31st, 1999. The baseline survey in the JPHC study assessed diet using 2 out of the 38 food and beverage questions in the baseline survey. One was about miso soup intake and the other was about soy foods, including soybeans, tofu, deep fried tofu, and natto. Isoflavone intake was calculated from the 2 questions. They used a validation study of 247 subjects that provided a 28-day diet record and urine and blood samples. From this, they determined that 80% of isoflavone intake was from miso soup and soy food. The validation study was conducted from 1994 to 1995 and confirmed portion sizes and isoflavone content in miso soup and soy foods. They also included other environmental data in the baseline survey. This was used to calculate relative risk ratios and was adjusted for history of benign breast disease, history of breast cancer in female first-degree relatives, smoking status, leisure time, physical activity, education level, alcohol consumption, total energy intake, consumption of meat, vegetables, and fruit, age of first period, number of pregnancies, menopausal status at baseline, use of exogenous female hormones, height, weight, body mass index, and age at first pregnancy. A cancer registry was also established for the JPH study on January 1st, 1990 to collect cancer data for the participants. Compared with women in the lowest quartile of isoflavone consumption, those in the second, third, and highest quartiles of isoflavone consumption had lower risk of breast cancer, as shown in the table below. Rates of cancer and relative risks were calculated from the categories based on their miso soup, soy food, and isoflavone intake. Comparing postmenopausal women to premenopausal women, both had an inverse relationship with miso soup and breast cancer. But as shown in the table below, you see that postmenopausal women had an inverse relationship with soy food and breast cancer, whereas the entire cohort did not have a relationship with soy food and breast cancer. This led to a stronger overall inverse relationship for isoflavone intake in postmenopausal women, with a p-value of 0.006. In conclusion, frequent miso soup and isoflavone consumption reduce the risk of breast cancer in Japan. The inverse associations between isoflavone intake and breast cancer risk was stronger in postmenopausal women than in premenopausal women, although overall there was no evidence for associations with soy food and breast cancer. The study was given a grade of B+. The analysis took environmental factors into consideration. The cohort spanned across several districts with Japan, including a variety of people. Researchers provided p-values and confidence intervals for their statistical analysis.
Now we are going to talk about the effect of dietary soy intake on breast cancer risk according to menopause and hormone receptor status. Women in Korea were interviewed, and after eliminating women with a history of breast cancer, women who did not cooperate, and women with no information on dietary intake paperwork, they got 358 women to be in the case group and 260 women to be in the control group. A dietitian interviewed to gather demographic, lifestyle, and current diet, including type of soy foods they ate. Other things the dietitian measured were physical activity, menstrual and reproductive cycle, and typical dietary intake. Things that were taken into consideration for organization of the analysis included intake of soy food and isoflavones, age, and multivariate models. The multivariate models were adjusted for age, BMI, family history of breast cancer, dietary supplement use, education level, occupation, smoking, alcohol consumption, physical activity, age at menarche, and total energy intake. Inverse association was only found among postmenopausal women with a p-value of 0.003. The protective effect of total soy intake was significant, with a dose-response relationship for the highest versus lowest quartile. Low quartile being low intake of soy, and high quartile being high intake of soy. The study reported an inverse association between soy food intake and the risk of breast cancer in menopausal women. The study was graded a C+ because it was a case control and there were few limitations, but it provided p-values and confidence intervals.
We gave an overall level of evidence to soy and reduction of breast cancer risk of a grade 2. The studies in our review were cohort and case control studies that each have their own design flaws and biases as a function of the type of studies that they are. They all employed food frequency questionnaires, which by nature are known to not be completely accurate, especially with regards to an individual's capability to recall foods that they have eaten, especially during childhood. However, the findings in our studies were pretty consistent across the board, and there were many studies to examine on the subject. The clinical impact of these studies may not be statistically significant enough to give a strong level of evidence. Many times, in order to see large reductions in risk, concentrations of isoflavones must be very high, something that is usually not achievable through diet alone in Western cultures. We are also not able to completely generalize the results to a Western population, as many people do not begin to consume soy products until they have a diagnosis of breast cancer or hear about its health benefits. Asian cultures, as stated earlier, consume soy on a weekly, if not daily basis. Therefore, they may experience more of the beneficial effects of soy than a U.S. Caucasian woman.
A serving of soy per day may reduce breast cancer risk as much as 50%. Eating soy throughout life, starting at a young age, has been shown to decrease the overall risk of developing breast cancer. Therefore, we recommend eating soy throughout the life, starting at a young age. We also recommend postmenopausal women to eat soy food.
Don't you forget about me.